talk about the data modeling, this concept. So a data model defines how your data is, right? We can have structure, store, relative. So it's kind of like when you have the database, how could you store your database? So this is very important when you want to define some common entities here. This normally you need to design the data modeling. And also this one, high level design, is also some like based on different performers necessary. They also need to use the right data model. So let's start from the first important part is called the database model options. We have the relational database, document database, and the key value store, and the graph database. So for document database and the key value base is something is called non-SQL database. So let's see, start from the relational database. Relational database is like MySQL. You can write a table. You can write a table here, which is called user table. So it's kind of like a Excel sheet. You can have the ID. This is row, right? This is column. Username, email, created time. So this is user table, and this is post table. For different entities, you can create table for them. So this is called a relational database. Like this one is like a table, just like a sheet. And another thing is which is called like MongoDB. It's a non-SQL database. It's stored as JSON file. Right, you can see here this is the something tag or something. Then this is the key. It's kind of like key value pairs, right? Username is key, and this is value. And also inside the post, you also have a lot of the key value pairs inside. So this is good for some data information you don't know the specific structure of the data. So it's good for use the JSON to store some important data. Another thing is the key value pair store. It's like Redis is the cache. So this is I will not treat like Redis. I will see like because Redis also stored as the JSON. So sometimes you can treat Redis as the non-SQL database. But the purpose for here is it stores the information in the memory. But for here is for the MongoDB, it's a kind of like store the information in the disk. So that's got a little different about this, but they all both belong to the key value pair store. So we can see here, let's see servers and check the cache key value pair if if this one is contain something, we don't need to go to the disk to find. We just directly return to the user. And based on the Redis, it's used the memory to store the information, so it's much faster to access the disk. So this is very useful for the improve the performance, low latency. So if the miss, then we'll check the database. Yeah. Another thing is called like a wide column database. So this is kind of concept means you can see this is kind of like a table, right? You can see this is row key. You can see in this way or this way. So it's kind of like two sides. So if you want to see in this way, then which means columns family post for here has the some like records inside. You have the post my first post hello world, right? And for here you can see you have the user, and for here, right, you can see here. See in this way you can see user. Okay, so current here they are posting something. These two records belong to the user one. So it's more flexible. So what about the graph database? Graph database is post, right? You can see here, post, like another there's a graph database. It's it's kind of like also non-SQL, but it's a stored is like a node and linked each other. So it's kind of like quite different structure as the previous. So it's like a user, right? It's pointed to something node here. So it's a one kind of database. Okay, let's see what is the schema design. There are three key factors. One is data volume, where can data live, right? Single database or distribute, you have to figure out. And the second one is access patterns. How is the data required? Draft index or the structure. If you right, so you have to design based on different situation. You have to pick up from high level. You have to design is the relative database or the non-SQL database. If the structure is, you don't have the structure, I use the non-SQL database. And if you have the structure, better use like MySQL relative database. And another thing is, the third thing is consistent requirements, how to treat, right? ACID is very strict. It's just only in the relative database have the ACID. In the non-SQL database, it don't have. So if requirements has the ACID, you have to choose the relative database. And for the eventually consistent, which means you just make sure the finally step, you can get the same date. So this one is kind of like you can choose the non-SQL or relative database. Both will be okay. So what about the entities and the relation, right? Relationship, right? So in the for example, is a good example in the relational database, we have the primary key. It means unique identifier for each record in a table. And foreign key, it points to a primary key in another table to create relational retry. And we have the user ID. Normally user ID as the primary key. And post another in this table is the primary key. And foreign key is, you can see here, user ID is pointed, it's kind of like a link, right? Use this user ID to link this one table. They match by the user ID. So this is how the foreign key doing. And likes, okay. Like something, I didn't create a likes database here. Okay. I think the like is another table. But the idea is this. Now, what is the normalization and the normalization? Normalization means store each pieces of information in exactly one place. User data lives only in the user's table, not duplicates across the other table. This prevents data, right, somewhere, how do you pronounce this one? Data. Anomalies where the update happens in one place but not another, leaving your system with the inconsistent state. So for example, we have the user table, right? So post the table. Normalize is like this. For here is duplicate, right? So we just remove this. And this information just only exists in one table. So this is how it look like. And for here is kind of like join this table together to create a single table, so which is called the normalization. For here, you can see they are just it's more like join the two table based on the information. And so next is about what is index of the access pattern. We have the B tree. It's a tree. So index in the database, you use the B tree it's kind of like the structure to store the information. Like for here is node, when you want to find which like specific like ID 35, you can find here and point it to this one. and it will keep going to the more detail about. But yeah, you can search by the tree and find what you want. You select where the age 50 here. So this is index for the pattern. Another thing is the scaling and shading, and sometimes the database we can, based on whatever the limits or when you have necessary need, right? So you have to better to create multiple database to support some records. So we kind of like we can separate like specific ID and store them like start from the 0 to 10K, start in the shadow one, in the database one, and rest of them is in the different database, and together to handle the servers, to give the users for the average performance. So the purpose is to handle the balance and also the and also because the database, when you access it, will encounter some limits. So if you separate by this, it's help to the load balance. Now let's wrapping up. So the first step is determine what type of database you are use. And second, list the column needed to fulfill the function requirements for each entity. And the third is specific primary and foreign key for each relationship. And four is determine which columns need index if needed. And five, determine whether you need to normalize for performance. Sometimes in the Redis you have to do that because the Redis is not store the whole information. And six is consider whether shading is necessary. If yes, choose the shadow key that match your main access pattern and in the context of your access pattern, date, volume, and consistent requirements. So we can see here, like normally when we design the database, we have this one. You can see here, this is choose the relational database. This is one of like a MySQL similar. And then we have the post table, user table, common, and this is the primary key, shadow. And this is foreign key, we have some index, right? So normally if you do a data entity, you better to write those information. Yeah, I think everything is here now. Yeah, thank you.